In English, if we talk about the meaning of the word absolute, you could think about it in the sense of someone with a very strong opinion. I absolutely disagree with you. I'm really not going to change my mind. Take that idea when we look at absolute value functions and the notation. So this is the basic absolute value function. As you can see, the notation for absolute value is this pair of vertical lines, which are a little bit like what I was doing with my hands when I said I absolutely disagree with you. You can see here, the actual function itself is those lines. They're solid, they're firm, and angular, just like my face turned out to be when I was being absolute. So that's just to help you remember it. Now we'll just talk about how this all fits together. The absolute value of x means the positive answer. So if I had the absolute value of 5, the positive answer of 5 is 5. But if I had the absolute value of -10, the positive of that is 10. So to get rid of the absolute value lines, we just make whatever's inside them positive. If I wanted the absolute value of 5 minus 2 minus 7, I would first have to calculate this. I can't just go and make those positives. I have to go 5 minus 2 is 3, minus 7 is -4, and then I can go the absolute value of that is 4. So when we do the mathematics, treat them like a brackets. 2 lots of the absolute value of 3 times 5 minus 8. Calculate this guy. Keep them there as the bracket would normally do, because you'd normally do the inside first. So what have we got? 15 minus 8 is 7. 2 lots of 7 is 14. And because that 7 was already positive, I can get rid of those absolute values anyway. If I look at the function, I can define it as a composite function. So the absolute value of x is actually made up of two functions, x and the negative of x. It will be x for x is greater than or equal to 0, and the negative of x when x is less than 0, because if it's less than 0, I have to negate it to make it positive. So my x function looks like this, would carry all the way through. The negative of x function looks like that and would carry all the way through. And there's the definition of that particular one. If I want to sketch a function like the absolute value of x minus 1, as is shown here, what I will do actually is just sketch the inside function first. So I know that x minus 1 cuts the y-axis at -1 and is 45 degrees. It's got a gradient of 1. It looks like that. All the positive y values will stay positive, but everything under the line is going to bounce back up and go back above. So my actual absolute value of x minus 1 function looks like this. An alternative way of thinking about it is to think, I know what the absolute value of x function looks like, which is that one, and then it's shifted forward 1 because that's what a minus on the x always does. I've sped these next couple of examples up so that you can see what's going on quicker. First, I've got to sketch the 4 minus 2x equation, which is going down, cutting the y-intercept at 4, but then bouncing on the x-axis. The next function that I'm going to attempt sketching here is an absolute value function that's then had a few shifts and adjustments to it. So I'll consider first the absolute value of x plus 1, and then there's a negative on the outside, so that means it flips upside down. So it's okay to have negative answers in absolute value questions if the minus is outside the absolute value markings, because that means everything inside it was positive, but then made negative afterwards. The plus 3 shifts it up 3 as per function moving. If I have to solve an absolute value equation, what I need to do is remember that this is actually a composite of two functions, one of them being 3x minus 1 and one of them being the negative of 3x minus 1. So what I could actually do is find out when each individually equals 5. Sped it up again for you here so you can see what the two solutions will come out as. In this situation, that's all I need to do because there's no tricky bits to it. If I were to sketch it, just so you can understand what the meaning is in sketch form, 3x minus 1 is a fairly steep function cutting through at -1, but we bounce it back up again, so it looks like this. And we're saying when is that equal to 5? And the answers are when x is 2 and when x is -4 on 3. So that's the meaning of what we just found. Take this one. I have two functions here. If I were to, well, I should say the best way of thinking about this is to, rather than put the positive in here and put the negative in here and solve them like this, A, you'll be doing it all day, but B, one of those answers might not actually mean anything. So if I were to sketch 2x plus 3, cuts through at 3, fairly steep, looks like this absolute valued, and compare it with the function of 4x minus 5, so we cut through at -5 for that one, and we're steeper again. So we're expecting this line, being not an absolute value, to only intersect at one point. And I know that that came from the positive side of my absolute value before I did the bouncing, because that one came from the bounce side. So I only need to do the positive version of solving on this. The 2x plus 3, don't put the negative out the front. That'll happen when x is 4, and that's the only time it'll happen.